From this equation, first we need to find the x-intercept and y-intercept. So from the equation x-intercept, we have to let y equal to 0. So negative x over 1 minus x plus 4 equal to 0. 1 minus x bring to the right side, and then we solve it. Then we get x-intercept equal to 2, 0. Next, we need to find the y-intercept. From the same equation, fx equal to negative x over 1 minus x plus 4. We let x equal to 0 and we will get y equal to negative x over 1 minus x plus 4. Substitute 0 into the x and we will get y-intercept, which is 0 to 4.
My name is Rana Line. My matrix number is 2022499526. For question 2b, we need to find the vertical and horizontal asymptotes. Before that, we need to find the denominator and equals it to 0. From the equation, fx equals to negative x over 1 minus x plus 4. And we need to cross multiply it. And the answer we will get is 4 minus 5x over 1 minus x. So we already get the denominator for vertical asymptotes. The denominator that we get is 1 minus x. We need to let 1 minus x equals to 0. And the last answer that we will get is x equals to 1. Next, we need to find the analysis of vertical asymptote. Lim fx, x approaches to 1 negative equals to lim x approaches to 1 negative 4 minus 5x over 1 minus x, and the last answer that we will get is negative infinity. Next is lim fx, x approach to 1 positive equals to lim fx, x approach to 1 positive 4 minus 5x over 1 minus x. The last answer that we will get is infinity, positive infinity. For horizontal asymptote, lim fx, x approach to positive negative infinity equals to lim fx, x approach to positive negative infinity 4 minus 5x over 1 minus x. And then we need to divide the equation with the highest number of x from the denominator. So we will get lim fx, x approach to positive negative infinity 4 over x minus 5x over x over 1 over x minus x over x. And then we will get lim fx, x approaches to positive negative infinity 4 over x minus 5 over 1 over x minus 1. Next, we substitute the equation with infinity. So we will get, we substitute the x with infinity. So we will get 0 minus 5 over 0 minus 1. So the last answer that we will get 5 is 5. So the horizontal asymptote is 5.
So for question 2c, we need to find the derivative, which is f prime x. So we are using fx equal to 4 minus 5x over 1 minus x. So to find f prime x, we are using quotient rule. So we set 4 minus 5x as u and 1 minus x as v. So first we need to let u equal to 4 minus 5x and differentiate it. Then we get u prime equal to negative 5, and we let v as 1 minus x and differentiate it, and we get v prime as negative 1. For second step of quotient rule, we need to use f prime x equal to v u prime minus u v prime over v squared. So just substitute it and we get 1 minus x multiplied with negative 5 minus 4 minus 5x multiplied with negative 1 over 1 minus x squared. So settle it down and we get negative 5 plus 5x minus negative 4 plus 5x over 1 minus x squared. We open up the bracket and we get negative 5 plus 5x plus 4 minus 5x over 1 minus x squared. So we settle it down and we get negative 1 over 1 minus x squared. Set f prime x as 0. Then f prime x, we have found the answer before, so substitute it and we get negative 1 over 1 prime x squared equal to 0. Bring 1 negative x squared to the right side and multiply with 0 and we still get 0. So negative 1 equal to 0, which is mean x has no solution and no extremum. F prime x is undefined. When negative 1x squared equal to 0, bring the power to the right side, so it will be square root 0. It's still 0, so 1 minus x equal to 0. Bring 1 to the right side, so we get 0 minus 1 and we get negative 1. But x need to be in positive, so we get x equal to 1. So we build a table having interval notation using negative infinity to 1 and 1 to infinity. As value, we are using 0 and 2 because it was between negative infinity to 1 is 0, 1 to infinity is 2. Sine of f prime x equal to negative 1 over 1 minus x squared. We substitute the test value into the sine of and we got both negative. If it was negative, the slope will be decreasing. So interval fx is decreasing, which is negative infinity to 1 union to 1 to infinity.
We move on to question 2D. Determine whether fx is concave up or concave down. We need to differentiate equation f double prime x. If f double prime x equals to negative 1 over 1 minus x squared, and we settle the equation, then the last answer for f double prime x we will get is negative 2 over 1 minus x cubed. Next, we let f double prime x with 0. From the answer that we get, which is negative 2 over 1 minus x cubed, we equals it with 0. Then we will not get the x value. The next step is f double prime x is undefined when 1 minus x cubed equals to 0. Then we will get the answer for x is 1. So the next step is we make a table for interval test value sine of f double prime x equals to negative 2 1 minus over 1 minus x cubed and the concavity. For the first table, for the first column, we put negative infinity to 1 and the test value is 0. The sine of f double prime x equals to negative 2 over 1 minus x cubed is negative and the concavity is downward. Next, for the next column, we choose one with infinity, positive infinity. The test value that we choose is 2 and the sine of f double prime x equals to negative 2 over 1 minus x cubed is positive and the concavity is upward.
For E, we need to use the original equation, which is fx equal to negative x over 1 minus x plus 4. We need to plug x equal to 1 into the equation, which is f1 equal to negative 1 over 1 minus 1 plus 4. We settle it down and we get negative 1 over 0 plus 4, which means it was undefined. So if it was undefined, it means there's no inflection point.
Last one, for this question, we have to sketch the graph by using all the information. The first step, we have to list all the information, such as y-intercept, x-intercept, vertical asymptote, and horizontal asymptote. So we got y is 0 to 4, x-intercept equal to 2 to 0, vertical asymptote is x equal to 1, and horizontal asymptote y equal to 5. The second step, we need to sketch a graph by using decimals, representing the x-axis from negative 6 to 10 and y-axis from negative 2 to 10. We insert this setting in the graph decimals and we will get the graph.
Next, for question 2, fs equal to negative x power of 3 plus 9x power of 2 minus 24x plus 2. For question 2a, find the x and y intercept. By using calculator, x-intercept let y equal to 0, and then you will get x1 equal to 0.08, x2 you will get 4.46, and x3 you will get 4.46, and y-intercept equal to 0. Substitute x with 0, and then you will get y equal to 2. So y-intercept equals 0 2.
For this question, we need to find the first derivative of the function. So from the function, which is fx equal to negative x to the power of 3 plus 9x to the power of 2 negative 24x and plus 2. We need to differentiate the function and we will get f prime x equal to negative 3x to the power of 2 plus 18x minus 24.
For question 3c, we need to find critical values and critical point. So we are using fx equal to negative x cubed plus 9x squared minus 24x plus 2. We need to differentiate it, so we get negative 3x squared plus 18x minus 24. We make it smaller by divide it using digit 3 and we get negative x squared plus 6x minus 8. So we factorize it and we get f prime x equal to x minus 2 and x minus 4. Set f prime x equal to 0, so we get x minus 2 and x minus 4 equal to 0. Critical value of x we get 2 and 4. So set x minus 2 equal to 0 and we get x equal to 2 and x minus 4 equal to 0 and we get x equal to 4. When x equal to 2, we substitute it into equation fx equal to a negative x cubed plus 9x squared minus 24x plus 2. So we get f2 equal to negative 2 cubed plus 9 multiplied with 2 power of 2 minus 24 multiplied with 2 plus 2. So we get the answer is negative 18. And when x equal to 4, we substitute in the same equation and we get f4 equal to negative 4 cubed plus 9 multiplied with 4 power of 2 minus 24 multiplied with 4 plus 2, and we got the answer is negative 14. So by that, we got the critical points, which is 2 negative 18 and 4 negative 14.
Construct the interval table and the interval where the graph of fx is increasing and decreasing. For interval station, we will get 2, which is the first one is negative infinity 2, and then 2, 4. For the test value, how we will get it is by number between of them, which is negative infinity, and 2, the number between of them is 1. While 2, 4, the number between of them is 3. So, how we want to know is negative or positive is by substitute the number of this value with equation f prime x, which is negative 3x power of 3 plus 18x. We need to substitute the x with 1 to get the answer, is it positive or negative. So for negative infinity 2, we will get negative, while 2, 4 we will get positive. If we get negative, the slope means decreasing. If we get positive, the slope means increasing. So for interval in fx increasing to 4, which is the slope is increasing, so the answer is 2, 4. For intervals fx decreasing, the answer is negative infinity 2 union 4 positive infinity. Question 3E, state the maximum and minimum point. So we will get the maximum and minimum point from the critical point. The maximum point that we get is 4, negative 14, and the minimum point is 2, negative 18.
Question f, we need to find the second derivative of the function. So from the function f prime x, we need to differentiate the function once again. So f prime x equal to negative 3x to the power of 2 plus 18x negative minus 24. So we differentiate, we got f double prime x and we get negative 6x plus 18.
Okay, for question G, the question need inflection point. This is we can get the inflection point by negative 6x plus 18 equal to 0, negative 6x equal 0 minus 18, negative 6x equal negative 18, x equal negative 18 over negative 6, and x we will get 3. When x equal to 3, that means fx is f3 equal negative x power of 3 plus 9x power of 2 minus 24x plus 2. And then substitute x with 3. You will get answer is negative 16. So the inflection point is 3, negative 16.
So for question 3H, we need to find concave up and concave down. So we are using equation f prime x equal to negative x squared plus 6x minus 8, and we differentiate it to get f double prime x, and we get negative 2x plus 6. Set f double prime x as 0, so negative 2x plus 6 equal to 0. Bring 6 to the right side, so we get negative 2x equal to negative 6. Bring negative 2 to the right side, so we get x equal to negative 6 over negative 2. And the last answer, we get x equal to 3, which is it was inflection value. So to find it was concave out or concave down, we are using table. By using the inflection value, we set the interval notation from negative infinity to 3 and 3 to infinity. The test value for negative infinity to 3 we are using 2, and 3 to infinity we are using 4. Sine of f double prime x equal to negative 2x plus 6. We substitute the test value into the sine of, so we get positive, and for 3 to infinity we got negative. So for the concave, if it was positive, we got concave up, but if it was negative, we are using concave down. So the interval with concave up is negative infinity to 3, and the interval for concave down is 3 to infinity. To find inflection point, we need to substitute our inflection value into the equation fx equal to negative x cubed plus 9x squared minus 24x plus 2. So we get f3 equal to negative 3 cubed plus 9 multiplied with 3 power of 2 minus 24 multiplied with 3 plus 2. And we get negative 27 plus 81 minus 72 plus 2. And the final answer is negative 16. So the inflection point, we put the inflection value which is 3, and inflection point that we get before which is negative 16.